Hello, my name is Grant Fritchie. I work for Redgate Software, and today I want to talk to you about design. Design's an important part of everything that we do, and the reason I'm bringing it up is because very recently there was a problem in Hawaii, in which inadvertently an emergency signal was sent out saying that there was, a missile launch coming in. Put your head between your legs and kiss everything goodbye, right? And it was wrong. It didn't actually happen. That wasn't what was going on. Someone inadvertently clicked the wrong thing. And you think, well, gosh, that's horrible. Maybe there should be processes in place to prevent this and all this other stuff. Yeah, and all that's somewhat true until you see the screen that was clicked on by accident. And you realize that, oh God, it's just down to core design. It's not that there was some horrific problem. It's not that their process was bad. Although, again, a better process, trust the process. A process is going to help you out. That's not the issue. The issue was simply that if you look at that screen, and I'll put up a shot of it here, it's horrible. I mean, it's just horrible. How is it possible that they hadn't had multiple mistakes by now? How is it possible that they didn't screw up 100 times already? With a screen like that, there's no way I wouldn't have made that mistake. There's no way. Just a moment of distraction, just that split second where you look and you go, PACOM CDW state only versus drill-PACOM state only CDW. It's like, well, I know which one I'm doing. I'm doing the PACOM state only CDW drill, right? Bang, you hit the wrong button. It's a horrible design. I mean, the most grossly incompetent person had to try hard to get to that design, which brings up databases. Recently been talking to someone online about their problems or issues, possible issues they're having with their database, and specifically with the table that it's 900 columns wide. Not the widest one I've ever heard of, by the way. Some of you seem to think that the column limit is a goal. It's not. Try to stay away from that. But the issue that they're running into is it's normalization. Well, it's slow. Normalization causes problems. Normalization slows things down. But if we flatten everything inside a relational database storage engine, if we flatten everything, it runs faster. No, no. The relational database storage engine is designed to run around relationships. It's designed to run with multiple relationships and a properly normalized or a properly designed star schema database. And so you break down your tables intelligently, correctly, carefully. You write your code against them intelligently, correctly, carefully. Even using generated code, something like an ORM tool. Entity Framework is fantastic, used correctly. And you generate the code the right way. You get these things done the right way. And then performance works well. What happens, though, is that the same people who designed this screen we were looking at earlier are also designing databases, evidently, because what happens is that they normalize badly. They normalize really poorly, and or they write their code against their normalization really poorly. And then they go, well, see, normalization sucks. And then they, it's like, well, if we just denormalize, we've arrived at this better place. And what's happening is it's all about design. You're not designing things appropriately so that you're not hitting these issues in the best way you possibly can. What happens is that you get really, really crap code and it runs badly. Shock, shock. And then you change it to mediocre code with a 900 column table and it runs way better than crap code. Instead of writing mediocre code, why don't we work on understanding exactly how relationships work, how relational data storage works, and write good code? Because good code is going to run better than mediocre code, which is obviously going to run better than crap code, right? That's it. That's all for today for me. My name is Grant Fritchie. I work for Redgate Software.